Previously, I have introduced the concept of a Raman spectrometer, but did you know that you can combine a Raman spectrometer and an optical microscope?
Microscopes are designed to examine small objects, so if we send a laser through a microscope, we can focus that laser on a very small part of the sample and collect the Raman scattered light. In this way, in addition to the microscopic image, we can obtain a Raman spectrum. With visible laser light, this combination is very easy. The measurement point can go anywhere the visible light could also go. That means we can measure beneath a material surface, in water, or through a glass window, or without sample preparation. The diffraction limit is the smallest distance that an optical microscope can resolve. This also applies to Raman measurements in a microscope. As a rule of thumb, this limit is close to half of the laser wavelength, typically several hundreds of nanometers for Raman microscopy. If we repeat this point measurement, we can have a bundle of Raman spectra with geometrical information. In the next video, we will learn how we can use a Raman microscope to create useful Raman images.